Okay, so I am explaining assignment 3. So this file right here is the implementation of the array fixed size stack data type. And yeah, so this is the constructor. It's pretty par for the course. You put in the max size that determines the size of the stack. Of note here is that it uses the abstract variable type t, but in array form. That means we can only use data types that are in array form also. So a string, for example, it's a array of chars, and we can use those. So here in this function push, this push is somewhat unique as it doesn't work like others, whereas others are the most common type is that if the stack is full, we just simply throw a Stack Overflow error. However, this one, we go to the bottommost element of the stack, and then we remove it to make room for the topmost element of a stack, and we put our new element at the top of it. So how it works in code here is that this basically checks if the top index is or if the array is full by checking the top index. And if it is, this for loop it iterates through the elements, and this line of code basically pushes every element of the stack down one. This implicitly removes the bottommost one, and it implicitly leaves room for the topmost space for the element. And then this line of code, it puts the latest element at the top. And then if the array isn't full, we just simply increment the top index one and put the latest element on top of there. So this reverse function, it returns a stack. So we got to make a new stack. So this for loop increments backwards. So it goes from the upper bound, or it goes from the max size of the stack down. So this one, it shoots pretty straight. It just goes down one each loop. However, this is the copy. And then we set it equal to the original, but we're incrementing upward through this negative sign, or through this minus operation. So we minus I plus 1 from the elements dot length. So that means we're starting at like 0, and then every time we increment, we go up. So this is incrementing upwards, this is incrementing downwards, and because they're opposite, they copy each other in reverse order. And then so then this line of code here, it just simply copies the top index. This is to make sure that the top index is not -1 for reasons we'll see later. And then it returns the copy. So here, toString, so we start off with empty string, and then the top index is -1, or if the top index is -1, we print out a stack is empty. That's why this line of code exists, is just to make sure that even when we copy it, it still makes sure, or it still tells the program, hey, this is a full string. And then else, this line here, it basically just tells us, that, or it just says, oh, hey, this is the top. It's just a nice presentable way of saying it. And then this for loop, it takes every element of the stack, and then it adds it to a string, and then it prints it out in a nice presentable way. This if else statement, it basically formats it well. So if it's the first element, top is already written next to it, and then all the other ones, they do a tab and then the element. So here is the array fix size stack driver. So in this one, it's just there to test, hey, is my program working? So I declared a new fixed size stack interface C with size of 4. So I push these 4 elements, and as expected, it's consistent because the capital J was the first one we put in, and in the original, it's in the bottom, which makes sense. Now, if we added in a fifth element, there wouldn't be a stack overflow. Rather, what we would expect is that this little j goes all the way on top, and the capital J is removed. And yes, it works that way. And so you may be wondering what this like number salad is. Wait, um, actually, wait, one more test case. Sorry. So this test case checks if the stack is empty. And because I removed all of the push commands, push calls, it is empty and it reflects in the text here. So you may be wondering what this character salad is, and that is because of the data type I use. So in the rubric, it said to use like more than one data type. I tried to implement int normally. Here, I'll show you. But it revealed an error, and that's because of the way it's structured. You can only use an array data type. So I made, all these arrays here, and I pushed them onto the stack. However, the print method, it prints the memory address of the it prints the memory address of the array. So it's like a pointer technically, and that doesn't print out well. But if you notice, it still works. It still has the overall correctness to it, although it doesn't look the best. And yeah, that's assignment 3.